Hello again. Thank you for putting up with the slightly manic morning session. This won't be so manic. Later on this evening, it will get much more manic as we do the actual loading. So be prepared for that. Can I just get a quick show of hands? Who's actually used any of this ONT technology before in some shape or form? I don't know, been in the same room. There's some of you. All right. So I want to start with going over a little bit of terminology because there are some terms that people use a bit interchangeably. This is a MinION device, and this is a flow cell that goes within a MinION. Lots of people refer to this flow cell as a MinION, which is very confusing. I may have done that in some of the instructions that I've given you, but hopefully you can work out what is what. So this is your actual sequencing device, and this is your sort of disposable cartridge that goes in that you load up, and that does that's got the pause in it that reads your sequences, that's interpreted by the MinION. We have a flongle, which is an abbreviation of something, but I don't know what, but it's essentially a mini flow cell. It's like a flow cell dongle or something like that. So that's kind of the same thing, but reduced down. Not so reusable, well, not really reusable at all. It's more of a one-shot use, and it's got less pores on it than your flow cell, so it's less powerful. This is your adapter. You can see different shapes to that. So you put your flongle in your adapter, which then goes in a MinION. Okay, does that make sense? So what's this one? Oh, who said flow cell? No. Flow cell. All right. I'm hearing a lot of grumbles, but I don't know if anyone's saying the right thing. Which one do I have in my hand behind my back? Nothing. Wow. So yeah, those are the four different parts. Thanks. Hello.
Is there one that you use? When do you use one of them?
So we use flongles pretty much all the time with us because we don't. Basically, if you use a flow cell, you can clean it and put it back in storage, but over time, those pores will reduce. We haven't been using them quick enough to want to do that, and they're more expensive. So we've been using flongles at the moment. We may change that as we go. We're also doing 3 plates at a time at the moment, and a flongle is great for 3 plates. Whereas with the increased pores on there, it might be a bit of a waste to use a flow cell at that expense just for 3 plates at a time. So it all depends on how much you're doing, how much outlay you can afford to do. There are slightly different chemistry kits for them, but that's mostly to do with the storage that the chemicals are in. So I think the plastic storage of some of the chemicals is shown to have maybe a little bit of an effect on the flongle. So, cool. Sorry. As I was saying, the flongle is more one-shot use. It's a lot simpler to load and to run. There are a lot more steps with a flow cell. We'll go through today with the flow cell, but during the practice, we'll use the flongle as well, just so you get an understanding of them. Boom. That's a terrible picture on there. Can't see a thing. So you can all have one of your own. I would recommend using gloves. We have used these. I've washed them with water, but who knows what's on them. We could probably get 2 per row. So yeah, you can open up the plastic packaging and just hold it like this. These, as I said, we've used these. You can bash them around, do whatever you want. There's no stress. Whee! So yeah, maybe not that recording. These will go back to be recycled. There we go. Everyone having a look at those? Cool. So, everyone see this? Okay. So down at this end over here, we've got the waste channels. Oh, even better. Wow. So this whole black area here. So if we say loosely, you've got the top here, which is where you've got a little sort of a window through, and then it says the spot on just beneath that. Let's take that as the top and the kind of snaking tail as the bottom. So what looks like a little window, that's where the pores are. So that is where eventually your sample will go, and that's where it pulls the DNA through and sends that electric signal, which is then interpreted as your read. The spot-on pore, you can feel free to lift that up. It's attached by a tiny little sticker, so it might just tear off. And one of them, I've put some autoclave tape to hold it on. But you can see underneath that little plastic tab, there is a little dimple, and that is your sampling port, which underneath the sampling port cover. Does that make sense? Can everyone see that? So later on, you'll be dripping your sample into that area to go into the pores. Here you have a little twistable bit here, which is your priming port cover. So closed is when it's sort of at a 90-degree angle to the way that the flow cell goes, and then open, it's pointing down towards the bottom of it. When it's open, you can see there is a hole that it was covering. That is your priming port. So later on, you'll be inserting primer into there to get the pores activated and ready to do their reads. When it's closed, you can see that there are two pores along the snaking area. The snaking area is the waste channel. So as you push primer in, the storage buffer that is on the pores will get pushed out and end up in that waste channel. And then you can suck that waste out and dispose of that later. I said that these are reusable. So later on, you can put in some more storage buffer and wash after you've done your sequencing, and that will push out the sequencing buffer with the samples on it into the waste channel that you can again clean up later. Flow cells. Oh, do you mind distributing some of these as well? Thank you. Flow cells are much reduced versions of that with no waste port at all. Oh my goodness. Minus points for me. Flongles are much reduced versions of flow cells, so they only have one port on them. And when you get it, you can see that there's a sticky bit that you can peel back, and it reveals a much smaller pore area and a little dimple in there, and that is where you put in your primer and where you put your sample in later. Can everyone see that? So yeah, during the protocol that we're doing later, we're going to be doing it for the flow cell. The flow cell, I've got it right this time. The flow cell is much more complicated to load because it has all the different steps. You need to prime everything, and then you'll also need to clean it up later and get it stored appropriately. So there are many more steps to that. Flongles are probably much easier to use in the field because you just basically pop one thing in and then another thing, and then you're done. So when you plug your flow cell into your MinION, getting it right, you can do a pore check, and you can see how many pores are remaining. And you can run it after you've done your sequence and you've put your storage buffer back in. You can check how many pores remain after the last sequencing run that you did. In theory, you can do it a little bit with this. We have had someone in our workplace suck out their previous run and run another one with different indexes because they would counteract, and it happened to mixed success. It was enough for what they were trying to demonstrate, but it was not something you'd recommend. Whereas this flushes out the previous run almost entirely, so you can have more freedom to reuse it with that. So you have your protocols in front of you, which is both a protocol for a flow cell and a flongle, or hopefully you have your protocols in front of you. I've tried to reduce down the official ONT protocol into as simple steps as I possibly could without losing all the important information. However, I haven't been able to create any diagrams that are any better than theirs, so we're just going to steal their diagrams and I'm going to talk over them. The bit that you're going to want to focus on is the loading the flow cell section towards the end of the flow cell protocol. We're going to entirely ignore all of the different chemicals and the mixing, we are going to use tap water. So people who've used flow cells and flongles before will know that there's a couple of points which absolutely terrify everyone. There's some terrifying part. This is where the whole session gets a bit scary. Yes. So your pores are incredibly sensitive to air. There can be absolutely no air that goes through the channel where you implant all of your buffer and gets to the pores. So the first thing you need to do is make sure that you are pulling out a tiny bit of that buffer to remove any possible air gaps that are in that channel. How people tend to do that is by, once you've opened up your port, you'll expose the priming port. You might see that there's some liquid in there already. That would be the water that I put in there earlier. But you might see that it looks kind of gray, which means that there's air in there. When it's wet, it'll look dark and black. When it's gray, it means that there's air in there. What you'll want to do is you'll want to grab a 1000 pipette, put it onto about 200. And pop a tip on it. So this is going into the priming port. Okay. Shall I actually bring up the priming port, which is the one that is exposed when you twist the priming cover? Once you've got that, try and find where the tip of the pipette fits comfortably into that priming port dimple. So it should kind of just sit in there quite nicely. And if you apply a bit of pressure downwards, it'll create a bit of a seal. We're doing the flow cell right now. But it's a similar technique when we get to the flongle as well. So you'll want to, this will all take place once you've placed it into the MinION and we're ready to go. But once you've got that little sweet spot where the tip of the pipette is in the dimple, you want to start twisting so that the numbers on your pipette get bigger. And very slowly, one at a time. And that will create a little vacuum that should pull out the storage buffer up to the dimple, meaning that any air in there should be removed. So, has everyone got their liquid up to the dimple of the port? Got a thumbs up from the back there. So now we're going to simulate putting in our buffer that we will do later. So we're going to put 800 microliters in. So we're going to take our buffer, our tap water as it's labeled, and set your pipettes to 800. I'll just flush it filled with water then. Just stick a load of water in it. Yeah. So if we put 18 in here, 800, sorry. Oh, is it empty as well? Let me quickly. So, if we've got our primer, if our port is ready to go, not the spot on, you want the spot on closed, sorry. The priming port, you've got your liquid up to the dimple, so you've removed any air. You'll then want to get your 800 in your pipette of fake buffer. So this one we're going to push in, but you'll see that you'll have a little bit of air gap in the bottom of your pipette tip. That's something you want to avoid getting into this channel. So you're going to go through to the same port here, but you don't want to then just introduce that little air bubble that you've got in your pipette tip. So as you're about to reach the port with your pipette tip, you'll want to very gently squeeze the pipette to push out that air bubble. If you drop a little bit of the fluid onto the dimple, that's great. That'll make a little bit of a seal, and then properly place your tip into the dimple, and then very slowly push your buffer through so that it covers the pores, and it'll push out the storage buffer that was in there, and you'll see that starting to fill up the waste channel. The key thing then is to make sure that you stop before you start injecting air in through the pipette. So if you remain with a bit of fluid inside your pipette tip, that's great. You'd rather more fluid left in the pipette tip than pushing air through into the pore. You can do that trick. However, you'd have to get down to like 0, and I worry about the health of pipettes. But if you'd rather do that, go for it. Oh, you can do with some. Some of them you need to like click into place. And so if you were to click it into place, you just end up shooting it through. So if you're at that stage, you should see fluid washing through into the waste port. If it's bubbling up out of the first, into the waste channel, sorry, if it's bubbling out of the first waste port, it's probably just because there's some built up salts elsewhere that are blocking the other port and preventing the air that's in there from coming out, so it's too much pressure. What's the question, sorry? Into the end, right there. And then making sure you remove the tip before you start injecting air into that port. Done that. There's the other port, which is the sample port. That is much easier to use later on. You essentially just drip your sample onto that, and it will kind of drink it up. It'll just, yeah, so it's, you don't need to worry about pressure and air bubbles. It'll just swallow it, and yeah. The same will happen on the flongle as well. It probably won't happen when we're demonstrating it. It probably needs to be actually for real. But yeah, so with your flongle, I've got it right this time. So you wanted to unstick this bit and then pull it all the way up to reveal that dimple. And again, you want to put your pipette on and just very slightly increase the number on your pipette to draw out that buffer that's in there and remove any air bubbles that might be in there. So very gentle. Give it another go. Yeah, it makes sense. It doesn't really matter what it's on as long as there's space to go up. You can't have it on 1,000. That's, yeah.